Hello, I'm Roman. Welcome back to the series of videos Neural Networks from Scratch in Golang, where we're using a book called Neural Networks from Scratch in Python, but we're writing everything with the Golang. I want to remind that I have a Discord channel you can join, and it's a pretty small community at this moment, but I believe we will be able to grow. Plus, again, I want to remind that I have another channel on the YouTube. You'll find the link in the description or in the pinned comment under this video. So there are a little bit different types of the video, but they all around tech industry and the coding in general. And in the previous video, I started to, working on the chapter, saving and loading the models and their parameters. And the main thing that I faced is there is a way to store, there is a default way to store deserialize and deserialize any struct, like the whole hierarchy of the struct, using the encoding package. Well, for example, for the encoding/JSON, for the JSON version, and I will go the JSON for now, just to be sure that I've done everything properly, because I visually can compare the data that is, from the debugging session, and I can open the JSON and, scan it with my eyes. But that requires a couple of things. Custom Marshall JSON. Okay. I think there is a Marshall. We can marshal any struct, for example, with these annotations. But the problem that in order to use this, all of the types should implement this encoding.text marshaller interface. Where is this one? But as you remember, for example, if we take a look at the layer, and actually all of the other, I'm using the dense struct from the Gonum, which doesn't have any of the attributes for the marshalling, which makes, for example, serializing of this layer struct nearly impossible. Well, there is only the regularizer that I can attribute for the marshalling, but that's it. And the thing is that I need to store the whole model. There is actually, for me, will be a question what I will do with the interfaces, because I could have, if we take a look at the implementations, there are various implementations of the layers interface. And plus, well, come on, you close. Plus, there are a couple of things, like for example, if we take a look at the finalize, maybe I can just call the finalize at some point, and that's it, because I will need to create the input layer. I need to define this, but the question is how to replicate this set, because the concrete implementations are passed. Plus, there is a array of the layers when it's the layer interface, and if you take a look at the implementations again, there is a layer, for example. Some reason that doesn't work. Okay. Wait. Okay. For example, we have the layer, which is actually a layer, but also we have, for example, the drop layer, which does some things too. Plus, we have lots of the activation functions that implement the same, And the idea to implement this is that for the forward method, we can do this. And the layer in that case could be an actual layer, a dropout layer, or any of the activation function. And this is how, for example, we can create things like this. And during the forward method, we'll just go through all of the kind of layers in this. But that kind of gives me, well, it kind of raises a couple of the things that I have no idea how to deal, at least for now, because I'm still learning the Go and I'm not sure how to do this. I mean, there is a only way. We actually discussed it on the Discord channel yesterday because I wanted to ask other guys' opinion on this, and the only way to actually do this is to implement the custom serializer, and instead of trying to, well, there are two actual possibilities. The first one is I can create something that I would call the DTO, data transfer object. So I will take only the data from the model and convert it into a specific, into a different hierarchy. The one that I can attribute with like this JSON attributes, and then I can use marshalling to save and load. And then I will have to do it like take the model, convert this into this DTO object, then save it, and then like in reverse loading, and then take the data from this DTO object and put it into the model. That's the first approach. The second approach is to write the serializer directly for the model struct, and kind of write the custom serialization. I will try the second approach, and I will probably write like save and load methods that will do this. I'm still not sure should it be a part of the probably it will be a part of the model struct itself, because I can, for example, during the training I can do how it's called, the checkpoints. For example, when one epoch is done, I can dump all of the whole model onto the disk. And for example, if something happens during the second training, I can start from the previous one. Also, if I want to tweak how I'm going to continue the learning after the specific step, I can load the checkpoint and continue going. So again, a lot of the talking. Oh, no, this one. Okay, so what do we do? Lots. So there are two functions I need to implement. First is save, surprisingly, and that will take paths string, and it will should return error if something isn't correct, right? So by default we return nil, and save, and that should be a part of the model, right? Same we have here, but that should be a lot. But this one is different, so that will be. Do I have the static methods on the Go? Okay, so the advice is to use the factory method. Okay, load model. it will take path and it should return either model or error, right? Okay, and by default it returns, okay, nil and nil for now. Well, the first what we need to do, well, before we go into the saving, we actually just need a couple of the things, right? So I used to work with the path, and I think this one, right? Do I need to properly do it here? Defer, press close. What is it? Street closer, yeah. What is F? File open reader. Actually, but IO open, no. Where's open, right? And we do path. And no, I need for the writing, like where is this reader? Get create. This is what I need. Okay, we have the file. Create, so turnkey is the named file. If the file already exists, it's turnkey. Okay, and in the load, I need nil error, and here it will be open because we need it for the reading. Okay. And I'm still not sure what I need. Okay, let's take a look. We need to start the we don't need to store the input layer, right? Because it just creates and okay. So we need the layers, right? I need to start commenting what I need to layers. Then output activation. Is it set somewhere? Yes, it is set on the finalize. Right? And I will need to call finalize actually. Call finalize after loading of the data. So then we have the loss optimizer and the accuracy. So the layers, loss optimizer, accuracy. Right? How many? I have the binary certificate categorical, yeah. Okay. There is a question. Well, I mean, I have too many questions, to be honest. how to marshal custom secret. For example, that's not here. See JSON Go an introduction to this package. Okay. In code JSON data, we use the marshal function. Okay, so there is a marshal. Given the Go structure message and the instance of the message, we can marshal a JSON encoded version of using JSON.marshal. Okay, in bytes. If all is well, error will be nil and B will be a slice of bytes containing the JSON data. Only data structure that can be represented as a valid JSON can be encoded. JSON object only supports strings as key to encode a Go map type. It must be a form of the map T. Okay, it's not like a channel complex, and function types cannot be encoded. I don't have this. Cyclic data structure not supported. They will cause marshal to go into infinite loop. We don't have it. Pointers will be encoded as the value they point to. Now it's the pointer is nil. Node. The JSON package only accesses the exported fields of the struct types, so that they begin with uppercase letter. Therefore, only the exported fields of a struct will be presented in the JSON. To decode the JSON data, we use unmarshal. First, we must create a place where the decoded data will be stored and call the unmarshal passing. Okay, so we pass in the bytes. For example, we can read it from the file and where to place. Maybe contains valid JSON that fits an M after there will be. Okay. How does unmarshal identify the fields in which to store the decoded data? For a given JSON K4, unmarshal will look through the destination structs fields to find in order of presence. Oh. Okay. What will happen when the struct of the JSON data doesn't exactly match the Go type? Unmarshal will decode only the field that it can find in the destination type. In this case, only name field of n will be populated and the full field will be ignored. The behavior is particularly useful when you wish to pick any of few specific fields out of the large JSON block. It also means that any unexported fields in the destination struct will be unaffected. What if you don't know the struct of the JSON? Okay. Generate JSON interface. The interface it describes an interface with 0 methods. Every Go type implements at least 0 methods and therefore satisfies an empty interface. Maybe that's my go-to solution. An empty interface serves a general container type. The type assertion calls the underlying concrete type. Or if the underlying type is a node types which determine the type. Okay. The JSON package uses map from strings, interface, and the array of the interface as well as to store arbitrary objects and arrays. We will unmarshal any valid JSON blob into a plain interface. The default concrete type Go types are blob or JSON, float 64 for numbers, string for the strings, and nil for the JSON null. Considering this JSON data stored, consider this JSON data stored in the variable p. So we have the name, we have the age, and we have parents array of the strings. Without knowing this data structure, we can decode it into an interface value within Marshall. Oh, okay, but how then we, at this point, the Go value in F would be a map. Those keys are string and those values are themselves stored as an empty interface values. To access this data, we can use type procession to access F's underline. We can then enter it through the map with a range statement and use a type switch to access. Oh, so it's an array. So this is basically the plain JSON parsing. Let's define a Go type to contain data from the previous example. Okay. And marshing the data into the family member value works as expected, but if we look closely, we can see a remarkable thing has happened. Really? With the var statement, we allocated a family member struct and then provided a pointer to that value to unmarshal, but at that time the parents field was a nil slice. That's true. To populate the parents field, unmarshal allocates a new line behind the scene. This is typical of how unmarshal works with the supported reference types. Consider unmarshalling into this data struct. If there were a bar field in a JSON object, unmarshal would allocate a new bar populated. Not bar would be left as a nil pointer. From this, a useful pattern arises. If you have an application that receives a few distinct message types, you might receive in struct. And the sending party can populate the CMD field or message field on top of the JSON object depending on the type of them. Marshal, when decoding the JSON into incoming message type, will only allocate the data struct presented in a JSON. Okay. The JSON package provides decoder and encoder type to support common operations. The new encoder, new decoder, and new encoder functions wraps the IOReader and IOWriter interface. Here's an example program that reads a series of JSON objects from standard outputs. Removes all but the name fields from each other and then writes the object to standard. Okay, so we have the decoder, the new encoder. So if we decoding from, so we're reading from the std, if we decoding it into the value, if we're decoding it into the map of string interface, then we're going through all of the elements, and if there is a name, we delete it, and then we encode it to the std out. For more information, see the JSON package documentation. Custom Marshall JSON. So for example, we have a type, well, we have the animal, we have the Marshall JSON. Now we pass in the bytes, the error, and then we okay. And we have the Marshall. Yeah, I would do this, for example, but if you take a look, for example, I cannot do this. for example. Yeah, met dense on Marshall be byte, and what is error, right? And return nil. Can define new methods on non-local type. Yeah, I need to. Okay, text Marshall. Yeah, but that's the same. There is an implementation of the text Marshall in interface, and then you can easily use the JSON on Marshall for the whole struct. I know, maybe creation of the DTO objects and annotating it with JSON attributes is not a bad idea. Because in that case, I will need to copy the data into another struct, but then I can just call, like JSON Marshall get the bytes, and that's it. And then I can store it in this blob of data into the file, and then do the same. Yeah, I want to play around with this approach in between videos. Once again, I tested a couple of the things yesterday, and I will try to replicate the simpler version of what I have. I still don't understand how it will work with the interfaces, and will be able to correctly load the concrete implementation. Maybe I will have to do this differently, but yeah, I will try to play around with this meanwhile in between the recordings, and hopefully I will be able to actually write in this implementation tomorrow, because I thought I will do this today, but I still have some questions and I need to do the research. But that's fine. This is the part of the software engineering that you do. It's better to research first, and then you will just know what you need to implement, rather than jumping into the implementation straight away and doing some, spending even more time doing back and forth. Not a good code. Okay, that's it for today. I don't have much time to record this, unfortunately, and I still need to do the experiments with this, so yeah, hopefully I will be able to do this tomorrow. But for now, thank you for watching, and I see you tomorrow. Bye bye.